Welcome to Study Loop.
Okay, so 102 is this sort of imaginary experiment, right? And we have three sort of plates of plants happening, right? So we have a plate A, B, and C. Okay, and then what's happening here is we're sort of seeing how many of them germinate or sprout seedlings, and these are all in the dark, so there's no light coming in, except plate A gets a little blast of red light. Okay, and then plate B gets a little blast of red light, followed by a far red light. And then C is going to be the control, so it's not getting any light. Okay, and then we sort of saw, well, what happened to the germinations? How many of the little plants started to sprout? And for plate A, almost all of them. We had 95%. And then plate B is at about 50, and plate C was at about 52, right? And if C is our control at 52, and B is at about 50, then you can think then that there's not really much difference between B and C. That margin of difference isn't very high. If this was a more rigorous experiment, you could sort of calculate statistical significance there. But for the sake of this argument, we would say they're probably not significantly different, right? And so what conclusions can we make? Okay. So then we're asked, well, does darkness inhibit germination? Does red light promote germination? Does far red light promote germination? Or is it independent from light? And so if it was independent from light, you would expect all three of these to be around the 50% mark. Okay. And if the far red light promoted germination, you would expect B to be the one that's doing the best. Okay. However, since A received this red light and then its germination went up drastically, you could presume then that the red light promotes germination. Okay, and then that something happened with the far red light to sort of counter the impact of the red light. So I would recommend some further experiments. We can, at least from this experiment, conclude that red light promotes germination. So the answer choice we're looking for is B.